In this Getting Started tutorial, I'm going to demonstrate how to design primers with Geneious Prime. To start with, I will demonstrate how to design new primers. In one of my files, I have a mitochondrion sequence from a woolly mammoth. What I want to do is to design primers that will amplify part of the COX-1 gene. To do this, I'll select the COX-1 gene annotation. Then I'll go to Primers and Design New Primers. I am going to choose Design New, as I want Geneious to design new primers for me. I will also ensure the forward and reverse primer options are selected to ensure the primer pair is designed. Note, it is also possible to design a DNA probe for TaqMan assays. When designing new primers, you can choose to have either a generic option, which is used when designing standard primers, or a specific option, which is used to amplify a specific region. For my example, I'll select a generic task. Next, I'll select to have the primers within an included region. This means my primers will be designed within the region I selected previously, which is the COX-1 gene. Alternatively, you can use the boxes to the right to specify a region of interest. If there is a specific part of the sequence that you want to amplify in the PCR, you can also set this by using the target region option. However, since I don't have a specific region of the gene that I want to amplify, I will leave this unchecked. For the product size, I will set this to be between 200 and 300 base pairs. I'll also choose to have an optimal product size of 250 base pairs, and generate just a single primer pair for this example. It is also possible to adjust the settings used for the melting temperature calculations by using the options underneath. For this example, I'll leave these settings as the defaults. Within the characteristics options, you can fine-tune the properties of the desired primers, such as the primer length, the optimal melting temperature, and the penalties for hairpins and primer dimers. For this example, I'll leave all settings as default, apart from the maximum melting temperature difference, which I will change to 2. This is to ensure both forward and reverse primers will have a similar melting temperature. Finally, I'll click the OK button to design the primers. A single primer pair has been designed within the gene. If I hold the mouse over each primer, I can see additional information, including the length, GC content, melting temperature, sequence, and number of off-target sites. Another way to design primers is to manually create your own. For example, if I highlight a desired region on my sequence, I can then select the Add Primer button next to the melting temperature. This will open up a new window where I can give the primer a name and select the direction of the primer. When I click OK, you can see that the primer I created has been added to the sequence. Before moving on to the next part of the tutorial, I'll press the Save button. Next, I'll show you how to extract the PCR product for a primer pair. To simulate the PCR, I'll go to Primers and then select Extract PCR Product. For this example, I'll choose to extract one PCR product, and I will use the primer pair that Geneious recently designed for me, which will give a product of 250 base pairs. Then I'll click the OK button. Now a new file has been created which contains part of the gene I was interested in amplifying. The primer pair annotations can also be seen in this new file. So that's an overview of designing primers and simulating a PCR. Primers can also be designed for sequencing. For this, I'll select a different file containing a mitochondrion sequence of the Asian elephant. Here, I'm going to design a series of sequencing primers to sequence the ND5 gene. I will select this annotation and then go to Primers and select Design New Primers. This time, I'm going to select Design for Sequencing as the task. Geneious can design primers for the selected region, in this case the ND5 gene, or it can design them for the full sequence. I'll leave this as the select region. It's possible to design sequencing primers that are unidirectional or bidirectional. I'm only going to sequence in the forward direction, so I'll stick with unidirectional. Then I'll choose to have primers every 300 base pairs. I'll leave the melting temperature calculator and characteristic settings as default, and click OK to design the primers. When using these settings, Geneious has designed 7 sequencing primers, and each are approximately 300 base pairs apart. Again, I'll save the file by clicking the Save button. If you would like to export these primers in a table format, for ease of ordering for example, then switch to the Annotations tab. From here, use the filter to select the primer bind annotations only. Then, you can select the Export Table button to export the primer details. For further tutorials on getting started with Geneious, refer to the other videos in this series.